Okay, this is cool. So we search for someone drinking and we can see that this system is able to return to us a frame with him drinking. Don't know what this is. I guess it looks like someone's drinking there. We see another frame with him drinking there. Then we see the frame with the can. So we're searching using natural language for specific part of the video. All right, guys, welcome to this channel. And in this video, we are going to be talking about a very interesting use case known as video intelligence or AI powered video search. We are going to be looking at what an AI powered video search application looks like, and you are going to come away with a good understanding of what video intelligence or AI powered video search is. But also, you're going to actually get some code. I'm going to give you a link to where you can access the code for the full application. Here is this video application that we built, and it's a very intuitive application, and it's very simple. I have a video, and what I want to do is I want to upload the video into this system, and then I want to search this video by natural language. I want to search for frames in the video by natural language. So we're going to talk a bit about what video intelligence is in more detail. But first, let me show you what we're actually going to work towards. This application, which you're going to get the code to, what I've actually done is very simple. I've loaded up some video, I've uploaded some video. I actually took a video of someone that I watch called Dom Ikovone, and he's like a fitness influencer, I guess, but he's also a business entrepreneur, family man, and he owns a bunch of fitness brand that he sponsors, and he sponsors some of the bodybuilders that I follow. I took one of his video and I uploaded it to this tool, and what I can do now is I can search by natural language for specific parts of the video. We're going to be talking about why this use case is useful in some scenario, but here is a look at what the video looks like. Yeah, it's a video that's about 16 minutes long. But imagine if I couldn't remember a frame in this video, or if I couldn't remember a scene in this video and I was just trying to start from a certain part. It would be very cool if I can just search by natural language from what I can remember about the scene, and I can then start with the frame, right? I can start from there. Then the selection takes me to the specific key timestamp on the video. So let's start with someone drinking. Okay, this is cool. So we search for someone drinking and we can see that this system is able to return to us a frame with him drinking. Don't know what this is. I guess it looks like someone's drinking there. We see another frame with him drinking there. Then we see the frame with the can. So we're searching using natural language for specific part of the video. So in this application that you're going to get a code to, when I click on this specific frame, the actual video, the playback here goes to that frame. So we're at that frame, and there's a text description. I'll tell you how this is generated.
You come meet my partner, bro. For real.
Okay, that's it, right? We can do another example. Someone looking at painting. Let's see. Okay, so we have someone looking, but we also have the actual scene of someone looking by painting that was ranked 2. There are 3 retrieval mechanisms that we're using to make video intelligence happen, or AI powered search. So we have hybrid, we have semantic, and we have text. I will talk very briefly as to what these search mechanisms are, but AI powered video search is an interesting use case. There's a lot of data, video data on the internet now. It would be so cool if we could just search using natural language. Now, the official, or I guess a technical definition of what video intelligence is the application of AI techniques, machine learning, computer vision, natural language, and using those techniques to actually analyze, extract, and get key insights and search for certain aspects of information within a video or video-based content. What use cases or what companies will actually benefit from this? So the easy one for me will be Netflix. The amount of times I want to search for a show, but I don't remember the title, and I remember maybe a scene or maybe what a cover image looks like. It would be cool if using Netflix, I could just type a natural language description of what I'm looking for, and it gives me a bunch of search results. Even better, it does it within the actual show itself, the actual movie, where you can search for certain keyframes. Imagine you're talking to a friend and you're trying to remind them of a certain movie scene, but you can't remember the movie, so you're just describing it. This extends to video editing tools like Descript, which I use, but also Adobe, and all of these video editing tools, all the way to video galleries and libraries on your phone, could also benefit from this as well, and YouTube search as well. So you can think about a different application of video intelligence or AI powered video search. What are the steps or the common typical steps that we're going to see in code, but also that you can see in pretty much a generalistic implementation of video intelligence? The first step is going to be frame sampling, or you can think of this as extracting the frame, the actual content of the frame. We're going to break down a video, right? A video is just images that are presented sequentially in incredible speed, in fast moving speed, right? So that's what video is. I butchered that definition, by the way. You're going to take a video, break the video into frames. You can do this every second, or you can look for maybe every 3 frames, you take the image and then you will pass that image into some of these machine learning models to detect objects, actions, text, logos, right? We're going to see that in action. Then the next step is for you to actually do some form of natural language query of some of these video content. You actually have to use something we call a embedding model. And in this particular demo and code that we saw earlier, we're actually going to be using a multimodal embedding model. But you generally want to use an embedding model to pass in the text or pass in the images and then extract a numerical representation of the data object, the images that was passed in. Next, you want to actually store both the embeddings and the images and index them in a database. This makes them searchable and makes it efficiently searchable as well. So you can also add your transcripts and any entities detected from the previous processes. Then last, you start to use the natural language to actually query some of the data objects in your database. You can look for a specific search text, like a frame where a red car overtakes a truck, right? That will get converted in this text will get converted into an embedding. Then we'll use it to conduct some form of retrieval mechanisms using our database and then get the relevant frames or clips. We are going to see this in more detail specifically to our use case. I'm going to go through some of these steps and I'm going to show you the corresponding code within the app code base. But let's go through this very quickly. So the actual steps we take in the implementation code is very simple. We ingest a bunch of videos, which is done in this process by dropping a video file here. Then once you ingest the video, we actually process the video using OpenCV, which is a Python library that is commonly used in computer vision and in typical video processing pipelines written in Python. I think there is also this library in other languages. Then we send a progress update to the UI just to show the processing of the video itself. Then in stage 2, we have this AI analysis pipeline where we actually use GPT-4. We use the vision capabilities and we use a multimodal 3. We're going to go into more details later. We take all of this information and we store it in MongoDB, which is our operational database to store both metadata and vector embeddings. Then we can have our intelligent search, right? Our AI powered search to retrieve information from our database using natural language. Here we're going to look at different ways of retrieving information that we've ingested in previous steps. So we're going to look at hybrid search, semantic search, and text search. Then we can actually take the results and show it like we saw in the actual UI. So we have the ingestion process, then we can actually load up a previous video and we can then search using natural language. So again, just to show you what we're doing or what we can do with this is we can search for a specific scene. The reason why we're using multimodal embedding model is because we can actually just search by text in the image, right? We can just use the embedding of the image that was generated to search for text in the image. We're going to talk more about this later, but let me just show you this in action. So imagine I can remember a scene when there was a text on the screen called new athlete, and I search it, and there we go. I can see the scene where it says new athlete. Now, this is not using any text data to do the search. It's using all visual data that was captured by the embedding model. And the embedding model was actually able to capture this specific word in the frame, in the actual image. And we're going to talk about the benefit of using multimodal embedding model, and we're going to talk about specifically the one that we used from Voyage AI. All of the code for this app is actually available in the Gen AI showcase. You can go into the app directory, and we have loads of other apps, but you go into video intelligence, and then you can read the README, and you can see the code for this. There's a back end, there's a front end, and it's very simple, but very powerful. So you can see how you can set up this code, have it running on your local, and you can follow along with this video. But very quickly, most of the stuff we're gonna be looking at is at the back end, because this is where the core functionality work is. And the front end is pretty self-explanatory. And there's a bit of setup you need to do, which this actually takes you through. We're gonna get all of this done. We're gonna go through some of the code. In the first step, we're ingesting the video and we're extracting a frame. What does that look like in the actual code base? We go into the back end, we have a bunch of services. And in this service, we have the video processor Python file. And one thing to note is we're using Fast API to build out the endpoints. From the front end, we have an endpoint called upload/upload, and this handles the uploading process. And once this uploading, this is where the uploading process is triggered. We validate the file, we check that we're not violating the file size, we're generating our unique identifier, and then we're saving all of the files. We're creating a path or directory to actually save this and actually create the actual directory itself. But the key thing is this process goes into the actual video processor service. Now, when you come into the video processor service, there is a process video function. This takes in the video path, the video ID, and we send a progress callback. We send a progress over back to the front end using WebSockets. We also have the MongoDB service and the AI service we're going to touch on later. So we've uploaded, we've dragged and dropped in the UI, we've hit the endpoint, and we've gone through the processes of setting up the folder, the unique ID. And what we're going to see here is within this function, what we can actually do is process the video. So the first thing we're going to do is we're starting to use the OpenCV library to process this video. So we use the video capture module to actually pass in the video by the path that is located, and we're able to actually process each frame in this video. We also extract some video metadata. This is useful for just storing the video metadata. We actually saw some of this metadata in the UI as well. So this is some of the metadata we saw in the UI as well that we extracted from that part of the code, the number of frames, resolution, the duration. So that's the metadata, right? We actually store this information as well in the database. So moving on with the process after you've uploaded a video, what you can actually see is we start to extract the frame and actually start to report on the progress. And this function, we can go into it right here. We have the video, we have the frames per second, we have the services, and you can see we're just going to do a couple things, right? We're going to look at how many frames we have because we need this to actually show the progress. And here is a quick tip. When you're just running this for the first time, you have an extensive video, maybe you just want to test it out, you can change this number to like a small number, like 100 frames or 50 frames, right? That will make the processing a bit shorter. But for now, we're using the maximum frames in the actual video. So we process the entire video from beginning to end. And that's what this is doing. So next, we read the frame and we're able to start to actually go through and process each of this frame. One thing you can see is we're generating a thumbnail, and you can see in the UI, we had this thumbnail of each of this frame. So this is how this is generated. It's a lower resolution thumbnail. We save it on our local, and we actually bring that to the UI when we conduct the search as well. This makes the UI more intuitive, so we know the specific part of the frame of the video that we're going to. And again, we capture metadata of the particular frame. Again, this is going to get stored in the database. All this metadata is very important and very useful. Next, we have this MongoDB service and AI service, and if we have them within our environment, we can actually go on and start to do more complicated processing. So far, we've done some thumbnail generation, we've done some metadata extraction of each of this frame. So let's go back into this function, process and save frame batch. Now, here is this process and save frame batch. So we're actually processing the video in batches. So we're not just doing it sequentially, and we're doing it asynchronously as well. So we have, for each batch, we actually create an array of the frame task, and we actually do this asynchronously for all of the frames as well. So we can look at this function, process single frame. So process single frame is actually very simple. For every frame we get, we're going to do one thing, which is we're going to generate a frame description. And this is using OpenAI API. We're generating a frame description because that allows us to conduct text search, right? And now one thing I'm also doing is generating an embedding of the actual frame using Voyage AI embedding. So one thing I'm going to do is let's go into the AI service, because this is really where the magic happens. So far, we've ingested the video, we've extracted metadata of the actual video itself, the resolution that we saw in the UI. We've extracted metadata of the frame itself and saved it on our local. But next thing we're going to see is this AI service, right? How are we getting the frame description and how are we generating the embedding? And we're going to go a little bit into multimodal embedding in this step. Now let's go back to the diagram and see where we are in our process. We've done step one, right? So we've generated the thumbnails. We're giving real-time updates via WebSockets to see the progress, but we're into the analysis pipeline, the intelligent aspect of this system where we're using some of the embedded models and also the language models, the multimodal language models that are actually very useful for this pipeline. So we're going to look at step two. I'm also going to look at step three. Again, you can go into the AI service that's located in the service folder. And in the AI service is where the magic happens. You're going to need to get a bunch of API keys. If you go through the README, you're going to see the API keys you need. And Voyage AI gives you 200 million tokens for free. So you can get your API keys and you can run an example for free. And you need an OpenAI key as well. Let's look at the particular function, generate frame description. How are we getting the description? This function, generate frame description, takes in an image path. So it goes into the image path, gets the image. We read the image. We make sure we have our client initialized. So we have an OpenAI client initialized. Then we're able to read the image. And then you can see we actually have a prompt. So we're going to analyze the specific frame. We're going to generate the description of what's happening in the frame. I wanted to look at the people in the scene, actions and activities, objects, and overall mood and atmosphere as well. And any text or graphics visible. This makes the actual text search much more intuitive as well. But I want it to be concise and informative, but keep it around 2 to 3 sentences. Now, what we're able to do is we do this asynchronously for each of the frame. We actually are able to call the completion API from the OpenAI client, and we can actually specify the model we're using, specify the user, and specify the content. Specifically, this is a vision-based use case, so we're going to specify the image URL here, and we have a base 64 image that we're passing in with a low detail. We're passing a prompt as well. So this is going to generate a bunch of text output. And what do this text output actually look like? We have example of the text outputs here, where we can see the video frame shows one individual seated at a desk. So we see that is also able to capture new athlete meeting. And this allows us this makes the text a bit richer, where we're then able to search by text. And let's look at that working, right? So this functionality only searches using text-based information from the data. So we can search new athlete, and you can see we get different results, but the top two is specifically the text, right? The text new athlete, not because we see it in the image, but because we have it in this text-based information. And we also have it here. But what is semantic? What is multimodal? What are embeddings? Let's look at the code of how we're generating the embeddings, so we could go a little bit deeper into what embeddings are. Remember, we get Voyage AI embedding, we pass in a frame, and we call on this function get Voyage embedding. Let's look at what that does. Get Voyage embedding, it actually takes in a data. We specify the input type, which could be document or query. Document is when you're ingesting and you're embedding. Query is when you have a user query. When we do the search, we actually want to embed that. This actually makes the embedding process more tuned to the specific task. We initialize a Voyage AI API, and we actually initialize a client, which then allows us to do a couple things. What we're able to do is call on the client and actually use the Voyage multimodal free. Now, this is a multimodal embedded model. Multimodal means this embedding model can take different modalities of data. Text and image can be processed by this embedding model. So you can send this embedding model a text, or you can send it an image. That's very important, and I'm gonna explain why. But the result of this embedding model is a numerical representation of the image that was passed in. Let's actually look at what an embedding model is, and at a very high level, how does embedding model work? An embedding model is basically a machine learning model that can take in data and capture the semantics and context of the data in a numerical representation known as a vector. So we pass in video, text, images, and now we actually have this neural network, and that can actually extract the semantics or the specific features of this actual data or this image, and capture the semantic in a numerical representation. Now that numerical representation is capture the meaning of the actual data object. What that means is we can then plot these vectors in a high dimensional space that has each axis for the number of dimension of the vectors. And actually what we can see is vectors that are closer together are similar in meaning, and vectors that are further apart are not relevant at all. Here you can see is a little bit flipped, going overboard with the visualization here. But here we can see we have an image of food and we have pizza. So a vector that captured food and a vector that captured pizza will be in the same area within or clustered together in a high dimensional space. So normally we usually have separate embedding model where you have the text input, like a red sports car, it goes through an embedding model, and then you get the numerical representation. Then if you wanted to capture semantics but based on images, you have to use a separate embedding model. And then for video, you have to use a separate one. So you can see how your AI infrastructure, your AI stack can actually start to expand. But what is the next best thing to do? Is actually to use one embedding model that can process text, images, video, and Voyage Multimodal 3 can actually process PDFs, right? Because PDF contains text and images, because what you would do is you can take a screenshot of the PDF and then process each of the screenshots into Multimodal 3, and you'll be able to extract some of the information and semantics of both text and images in the same latent space, right? And that saves a lot of processes. It saves a lot of components within your AI stack. And there is an extensive blog that talks about Voyage Multimodal 3, and it goes a lot into detail as to how it works. But the key thing is Voyage Multimodal 3 allows for interleaved text and images for maximum flexibility. And the reason why we can use it for video is because a video is just several images presented one after the other. So, and video is just a bunch of images. So we can actually break them down by frames and again, process this images into Multimodal 3. What does that look like in practice? Remember, we had this text. We're searching for these frames using the actual text-based data that we extracted from the frame, right? But now we can actually use just the embeddings, right? So we switch over to this search mode and we can just search for new athlete. We've done this already. So the top two is new athlete, and it's not using any of this. So you can look into the process. We're going to look at that later. It's not using the text data. It's only using this information from the image itself, but it's captured the semantics of this. It's captured this specific new athlete meeting because Multimodal 3 can understand text in images, hence why it can understand images of PDFs. Okay, so let's look at another example, like pointing, right? Someone's pointing, and now we can see what we get. I don't know why these are coming up. I got to look at why these are coming up, to be fair. But here we can see we have someone pointing here, we have someone pointing up, and we have someone pointing there, and we have someone pointing here, right? And you can see over here, there is no pointing in the text description, but we're able, just to make sure, fact check myself, right? There is no pointing in these text description, right? But we're able to actually see this pointing motion being captured in the semantics. So let's look at another example. For example, lying down on a chair. right? Now, let's see what that would look like with semantic search, right? With semantic search, what you have is we get the scene of someone actually lying down on a chair, right? From the image. So the image understands that the embedding, the numerical representation that was captured understands the person is sitting on the chair. We capture that semantic, and lying down on the chair is able to give that as the first result. And here we see someone sitting down as well. Similarity scores are important for vector embeddings and semantic search as well. If we're to do the same in search, we will get different results. So sometimes you might see search is not really, the text description did not capture that specific scene, which is fair because, again, this is why you probably want to use more robust search method. Now, that takes us into the realm of hybrid search, right? With hybrid search, you get the best of both worlds. So we say, what does it look like when we combine both of the search methods? So you can see we rank the search results by text, and we have the search results by semantics, and then we're able to then see both results from both of the searches. But this is really the relevant one, right? The rest of it are a bit irrelevant to the specific scene. Semantic search works best for that search query. There is no one search is the best search. Really, what I tell my customers is evaluate, right? For your specific use case, the type of queries you expect people to pass into your system, evaluate and look at what search methods work best and the parameters of the search method. Let's look at the MongoDB service that makes all of this search actually possible. If we go back to the main.python file, we can see that we have this endpoint/search. So every time you enter a text into the search box, it hits this endpoint and it goes through a bunch of processes. The most thing to actually understand is, by default, we're going to use hybrid, or you can just click on the search mode that you want to use, then you will use that as the search type. But for these searches, right, if the search type is not text, right, so if we're doing hybrid or we're doing semantic, we need to actually generate an embedding of the query coming in, because we're not just searching by text, right? We're searching using numerical representation of data objects, including text. So we have this function called getQueryEmbedding that takes in a user query and generates a numerical representation of that query itself. For example, someone lying down will be passed in through the embedding model, and what will be generated is a numerical representation of that query. And what that will allow us to do is we can use the MongoDB service, right? If the search result is semantic, the search type is semantic, we can actually call the semantic service. If it's text, we don't need to pass in any of the query embedding that was generated. We just pass in the query. But if it's hybrid, not only do we pass in the query, we pass in the query embedding. The best one to show would be hybrid in this case. Here is hybrid search. For hybrid search, we're using both vector search, which is semantic search essentially, and we're using text search. And I'm going to show you how it works using MongoDB. In MongoDB, we have the ability to create a pipeline that has stages within them, right? So we're going to create a vector search stage. We're going to use the vector search operator. You can look at the MongoDB documentation to learn more on this. But we're going to use the vector search operator. And what this does is it says we have a query vector, which is what the user has passed into the system and converted into a numerical representation in our pipeline. We're going to use that to look for any relevant other vectors in our database that are actually similar to this query vector. We're also filtering by the specific video ID. This makes our retrieval process more efficient in some cases, and we don't have to consider other videos that are not relevant to the one that we're looking at. If we have we have loads of data of multiple videos. So that's the vector search stage. For the search stage, it's actually quite simple. We use our index, our text search index, and we actually use the query text, right? We actually use the actual text query, not the embedding. This is actual text query. We specify the path, which is the description of the frame that was generated by GPT, and we're going to use that to conduct the text search. Now, what we can do is very simple. We can actually do this. We can then use the rank fusion operator that uses both the vector index and the text search index, combines it into one pipeline that uses both vector search and text search, and actually takes into consideration some of the weights we want to add. Let's say you want to lean more towards vector search. This would be more maybe 0.7. You want, and this will be 0.3, because both combined needs to actually equate to 1. And then you can actually pass the result. You use the aggregate framework to process this pipeline, and you get a bunch of results. And that's what we see here. We see this bunch of results on our screen. Now, that's it really, right? It's very intuitive, versatile use case, very useful. Let's see what the data looks like in MongoDB. In my MongoDB database, and what we can see here is in this cluster, I have a bunch of databases, but the one that we're creating with this specific app will create a database called Video Intelligence. If we go in here, we have 2 collections. We have the frame intelligence and we have the video metadata. The video metadata contains 4, because I processed 4 videos, and in the frame intelligence we have around 5,000 documents. Let's look at what the video metadata looks like. So the video metadata is very simple. We capture the duration, the frames per second, the resolution, right? Very simple. We also capture where the video is located. This is for the playback. But obviously, just for experimental purposes or proof of concept, this is being stored on the local machine. Ideally for production or even for MVP, you're going to be looking to store this on some cloud storage. Now let's look at the frame intelligence, because that's where the magic happens. So this captures all of the frame information. So remember, the metadata of the frame, we look at the frame number, we look at the timestamp of where the frame has occurred, where we've captured the frame. We have the thumbnail path for the frame as well. This is, again, stored on local. You can store this on a cloud storage for production use cases. Then we have the metadata of the frame, resolution, and the original frame number, right? Then we have the description. So remember what we actually have from OpenAI, from GPT. This is actually created here and stored here. But alongside that, we have a vector embedding. And a vector embedding is just a numerical representation of data object. And the data object was the image that was passed in. So when we conduct hybrid search, we're using both of these attributes, the description and the vector embedding, which we have a more richer search experience. But when we conduct text search, we are just using the description. When we conduct embedding, semantic search, we're just using the embedding. And that's it. That's video intelligence. We went through a lot in this video, but we got through to the end. We learned a lot as well. And we've seen ways we can start to build some AI-powered video search into our applications with different modalities for processing data, images and videos and text, but also different ways to actually retrieve data. So hybrid, semantic, and text. Thanks a lot for making it to the end of this video. I hope you got a lot of value from this, and I'll see you in the next video. Don't forget to like and subscribe, and take care.